back to the class. We were discussing several parts of this chapter, sets. We discussed, lastly we discussed union, intersection, and the difference of sets. Now I am introducing you a new concept or a new diagram which was proposed by the mathematician John Venn and named it as Venn diagram. Venn diagram. This Venn diagram helps us to make our operation very easily. Let us start. See here. Suppose A is a set. A is any set. Any set. Suppose 1, 2, 3, 4. B is equal to, as we discussed in the last class, 3, 4, 5, 6. Then what is A union B? A union B is equal to the join of all elements of these two sets A and B. That is 1, 2, 3, 4. Set 4 is covered. Then again B, 3 and 4 are repeated, so can be avoided. Then 5, 6. This is the union of both A and B. This can be described by using Venn diagram. For that, I am drawing a rectangle or rectangular box here. In Venn diagram, we name this box or this rectangle as the universal set. Universal set. Universal set. So this box or rectangle is named as what? Universal set, a big set under consideration. Okay. Then it is A and it is B. There are two sets, A and B. When we draw Venn diagram and when we represent two sets by a circle, we are drawing these two circles in overlapping mode. This is A and it is B. Because what this part is what? This is common for both A and B. That is the intersection part. In this question, A is equal to 1, 2, 3, 4. B is equal to 3, 4, 5, 6. Their common parts are what? 3 and 4 is common. That is 3, 4 here. 3, 4. 3 and 4 can be seen in the common part, which is the intersection of both sets. Then what are A? 1, 2, 3, 4. A 1, 2, 3, 4. So A is completed, isn't it? 1, 2, 3, 4. Then what is B? 3, 4, 5, 6. 3, 4, 5, 6. Okay. There is no separation with the commas. This can be written everywhere in the sets A and B. Okay. So A is equal to what? 1, 2, 3, 4. That's okay. B is equal to 3, 4, 5, 6. Then clearly A union B is what? A union B is a join of both A and B. 1, 2, 3, 4, 5, 6. No elements are repeated. Clear? 1, 2, 3, 4. That's A union B is clearly seen as what? 1, 2, 3, 4, 5, 6. A union B. And A intersection B is equal to what? A intersection B is a common part for both A and B. That is, common part means this area 3, 4. 3, 4. So this is a method under the diagram, Venn diagram, which was proposed by the mathematician John Venn. Okay, generally for representing A union B, it is universal set. This set is A. This set is B in overlapping mode, overlapping or interconnecting mode, A and B. Then A union B is a join of both A and B. So we can shade here A. A is shaded. Then similarly B is also shaded. This is what? A union B. Clear? So A union B can be marked by using Venn diagram like this. This is a method proposed by the mathematician John Venn. Once again, A and B are given, and by using Venn diagram, we can represent its union as well as intersection. So to represent a union of the sets, first we are drawing a rectangular box and it is named as universal set. For every question under Venn diagram, this box will be represented as what? Universal set. And inside the universal set, we are drawing required number of sets. Here A and B are given, so A and B are drawn. Before drawing, we must have the idea to draw these two sets by circle mode, and it must be in overlapping mode because what these A and B have what common part 3 and 4, isn't it? So 3 and 4 can be written in the common part, which is the intersection. Then A union B means what? The complete portion of both A and B, or join of both A and B. That is 1, 2, 3, 4, 5, 6. A union B. And similarly, A intersection B can also be drawn. A intersection B. A intersection B is equal to what? Common part is 3, 4. 3, 4 is the common part. So A intersection B can also be drawn. This part 3, 4. This part is the A intersection B. By using Venn diagram, we can draw A intersection B. A intersection B. This is universal set. Set A. Set B. Then what will be A intersection B? This common part only. This common part is A intersection B. Clear? So A union B and A intersection B are drawn by using Venn diagram. Okay. Another term, complement of a set. Just very simple, complement. By using Venn diagram, we can illustrate the idea behind component of a set. For drawing Venn diagram, firstly we are drawing what? A box which is called as universal set. Universal set U. And now representing a small set A. A is a set. Clear? So only one set is given, that is A. Clearly A is a part of the universal set, isn't it? A can be seen inside the universal set. Universal set is a big set, isn't it? Universal set is a big set under consideration. What we are considering in this question, that the big set is called as what? Universal set. Okay. When natural numbers are considered, uh, natural numbers means capital N is equal to set 1, 2, 3, 4, 5, etc., 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 up to infinity. Infinity is still unknown, isn't it? So natural number set can be taken as one universal set. When your classroom is taken, all students in your classroom can be considered as what? Universal set. So this means universal set is a big set under our definition or under our consideration, isn't it? അപ്പോൾ നമ്മൾ ക്വസ്റ്റനിൽ എന്താണോ വലിയ കാര്യമായിട്ട് പറഞ്ഞത് ആ വലിയ സെറ്റിനെ എന്ത് പറയാ? യൂണിവേഴ്സൽ സെറ്റ്. അപ്പോൾ യൂണിവേഴ്സൽ ഡെഫിനിഷൻ ഓഫ് യൂണിവേഴ്സൽ സെറ്റ് മേ വേരി according to the situation or according to the question. For this case, I am taking a simple set A and a universal set U. So definition of universal set is what? It's a big set. That's all. Okay. So clearly A is a part of U, isn't it? A U ilanullathu. So A is a part of U. Okay. A is a part of U means what? A is a subset of U, which we have learned, isn't it? A is a part of U or A is a subset of U. Then, so this area, when I am shading here, this portion will be what? A, the set A. Now I am shading other part of A here. This part is shaded, just like a sun, isn't it? This part is shaded. This part means the part beyond A and within the universal set beyond A. Okay. So shaded area means what? Area inside the universal set but other than A. This shaded part is called as the complement of A. Complement of this set. So what is complement of the set A? Complement of the set A is nothing but it is set, but it is a set inside the universal set other than A. A അല്ലാത്ത കാണുന്ന ബാക്കി ഏരിയ ഫുൾ അതിനെന്ത് പറയാ? A complement. A complement can be written as A complement. A raised to C, just like that, A raised to C, AC, A complement. Or it can also be written as A dash. Usually in your question paper, A dash can be seen. So A dash or A complement is a representation of the complement of the set. Here this is a complement of A. Similarly, this is A complement. A complement. Then I am drawing another Venn diagram, a box here which represents universal set U, and I am drawing two sets such as A and B. A and B. Okay, clearly we have this area is what, this portion is what, A intersection B, and I am drawing other part of A intersection B. This is other part of A intersection B. The whole part other than A intersection B is shaded within the universal set. Okay, so just this part is avoided and all other parts are shaded. Then this shaded region will represent as what? A intersection B is this one and its other part. So A intersection B complement. So this is A intersection B complement. Similarly, third Venn diagram, universal set U, a set A, another set B. This part is shaded. This part means what? The area other than A union B. A union B is this one, total or join of A and B. Total of A and B is what? A union B, and shaded part is other than A union B. So this shaded part represented as what? A union B complement, or C, A union B complement. Okay, so this is the idea of complement of a set. Okay, this operation, difference of sets, A difference B and B difference A. What is A difference B? A difference B is the set of all elements in A other than B. So let us discuss this A difference B by using Venn diagram. For that, firstly we are drawing a universal set. Universal set U. Universal set, and A and B are given. This set A, this set B. Two sets A and B are given. A difference B means what? All elements in A but not in B. A difference B എന്ന് പറഞ്ഞാൽ എയിലുള്ള എലമെന്റ് മാത്രം എടുക്കാൻ പറ്റുള്ളൂ, ബിയിൽ എടുക്കാൻ പറ്റൂല, ബി മാറ്റണം. So A difference B means set of all elements of A but we can't touch B. B തൊടാൻ പറ്റൂല. അപ്പോൾ ഏതാ ഷെയ്ഡ് ചെയ്യണ്ടേ? This one only. This is what? A difference B. Why we didn't shade here? Because this part represents B also, or this part lies on B also. This is a only part for A, general part for A, or common part, unique part for A. This part is common for both A and B, so we can't shade here. Isn't it? So this shaded part is what? A difference B. A difference B. Once again, A difference B means what? Elements of A but not in B. That is the definition. Elements of A, okay, but not in B. So this is B only. This is for both A and B. This is for A only. So this shaded part is what? A difference B. Similarly, this is first question. What is second one? B difference universal set U. A and B are two sets. B difference A means set of all elements in B but not in A. Set of all elements in B but not in A. Clear? It is very simple beyond further discussion. Very simple. It is what B difference A. B difference A. So A difference B and B difference A are drawn by using Venn diagram. See this question. Prove that A union B whole complement equal to A complement intersection B complement. This can be proved by using the idea of Venn diagram. So in this question there are two parts. This is left part and right part. Left hand side, right hand side. So we have to prove both left hand side and right hand sides are same. So firstly we are taking left hand side. Left hand side. This is left hand side. A union B whole complement. Okay. After that we will find what is right hand side. Then we have to check both left and right hand sides are same. So to describe this A union B whole complement, firstly we are drawing what? A universal set U. Universal set U. Then A and B are also drawn. A and B are drawn. Then what is A union B? A union B means whole region of both A and B. This region, isn't it? This region. That is, this is A, this is B, and A union B means what? The whole region. Join of both A and B. Then A union B complement means what? Beyond that region. Beyond that region. So A union B is shaded here. A union B. A union B is this one. This is A union B whole complement. A union B can be seen here without shaded, and A union B whole complement is what? This shaded region. Shaded region only is the A union B whole complement. So this figure represents for what? Left hand side. Similarly, what is right hand side? Right hand side. Right hand side is what? A complement intersection B complement. For that we are again drawing same sized universal set because we are going to prove these two concepts. So you should have similar figures, similar box. Suppose its length is 5 centimeter, breadth is 4 centimeter, then same measure shall be used here. Okay. A and B, same A, same B. Two identical figures A and B. Here A complement intersection B complement. So first you mark A complement. A complement means what? Other than A. A is this one. Other than A. Other than A means beyond A. This is A complement. A. Beyond A. Other than A. So all the region were shaded. That is A complement. Then what is B complement? Other than B. B is this one. So other part of B can be shaded. So firstly I am drawing or I am shading by using horizontal lines. Now to represent it is for B, I am drawing vertical lines for B. Okay, to identify only. So B complement. It is B complement. B complement means what? Other than B. Okay, other than B means including A, other than B. So only B is freely spaced. Okay. So this common shared part, look this common shared part. Common shared part represents forward A complement intersection B complement. Horizontal shared part for A complement, and horizontal means these lines. Horizontal lines represents for A complement and vertical lines represents for B complement. So I am using two types of shading region because for to identify, one is for A complement and other is for B complement. So horizontal lines represents A complement, vertical lines represents B complement. Then what will be the both horizontal and vertical lines represent for? That is representing for both A complement and B complement. That is A complement intersection B complement. Right? Horizontal lines A complement കാണിച്ചു, vertical lines B complement കാണിച്ചു. അപ്പോൾ both horizontal and vertical shadings represent for what? Their intersections. A complement intersection B complement. So what is A complement intersection B complement? This shaded part. A complement intersection B complement. This region, E region ആണ് A complement intersection B complement. So look here, it is what? A union B whole complement. See these two regions. A union B whole complement is this region. So left hand side is this region. Right hand side means A complement intersection B complement. That is the same region, isn't it? Same region. Okay. Shadings are different because here two types of shadings are used, right? That is to represent A complement and B complement. Here A and union B means it is a single one other than A union B. So at a glance it is very clear that both left hand and right hand sides are same, isn't it? So therefore what? Left hand side equal to right hand side. Hence the proof. Hence the proof. അങ്ങനെ നമ്മൾ പ്രൂവ് ആക്കി. ലെഫ്റ്റ് ഹാൻഡ് സൈഡും റൈറ്റ് ഹാൻഡ് സൈഡും ഈക്വൽ ആണെന്ന് നമുക്ക് വെൻ ഡയഗ്രത്തിൽ കിട്ടിയതുകൊണ്ട് അത് പ്രൂവ് ചെയ്തു. വൺസ് അഗെയിൻ we have to prove A union B whole complement equal to A complement intersection B complement. This type of question is introduced by the mathematician D. Morgan. D. Morgan. Therefore, this question or this theory is called as De Morgan's law. De Morgan's law. So what is De Morgan's law? A union B whole complement is equal to A complement intersection B complement. So you have to learn by heart this theory or this law. A union B whole complement is equal to A complement intersection B complement. That is De Morgan's law. To identify A union B whole complement by using Venn diagram, firstly we are drawing a universal set U and both A and B are drawn by overlapping mode. Then A union B is very clear. This non-shaded region is A union B. Then other part is called as what? A union B complement. So A union B is its complement. A union B complement is very clearly here. That is shaded part. A union B complement. Then right side is taken A intersection, A complement intersection B complement. For that we are also taking another box which is similar to this box. Both these two boxes must be same size. Then A and B are drawn, and A complement. To draw A complement, firstly we are shading. A complement means other than A. A is this one. So other part of A, complete other part of A are shading. Are shaded. Then these shadings are by using horizontal lines. So by using horizontal lines, I am shading all part other than A. Other than A is avoided. Only A is avoided. Then B complement means what? That is shaded by using vertical lines. B complement means we can't touch B. All other parts of B can be shaded. So all other parts are shaded. So here B is only free up. B മാത്രമാണ് ഫ്രീ ആയിട്ടുണ്ട്. Then look at the common part. Common part is the intersection. So why should we look at common part? Because we have to inform that what intersection, a common part is to be found out. So intersection means what? Common part. Common part means what? Included area of horizontal and vertical lines. Here horizontal and vertical lines can be seen this part which is similar to this part, isn't it? That is A complement intersection B complement. So both the area or both the space, both the region for these two figures correspond to this question are same. Therefore, A complement intersection B complement is equal to A union B whole complement, and hence we proved this concept. This concept is developed by the mathematician De Morgan, and therefore this law is called as De Morgan's law, which is to be learned by heart. Okay, just like another law under De Morgan's theories. A intersection B whole complement is equal to A complement union B complement, which is just similar to first question. What was first question? A union B whole complement is equal to A complement intersection B complement. Look at here, this union is replaced by intersection, isn't it? Similarly, this intersection is changed by the union. Then position of union and intersection. Look at the questions. A intersection B whole complement, which is equal to A complement union B complement. So firstly, we are taking the left hand side. What is left hand side? Left hand side is A intersection B whole complement. Firstly, taking a universal set U, and A and B are drawn. A and B are drawn. Then A intersection B, it is very well. A intersection B is this small region. Its complement means other than that region. So all other region are shaded. Clear? So this non-shaded region is what? A intersection B, which is common for both A and B. Then its complement means whole other region. That is A intersection B whole complement. Then take right hand side. Right hand side means it is also a same box. Universal set U. Similar type of sets A and B are drawn. AB. Then what is RHS? Left right hand side, A complement union B complement. A complement. A is this one. Its complement means other part of this A. Whole other part of this A. Yes. It is what? A complement. A complement. Union B complement. What is B complement? B complement means other part of B is here. B is here, and whole other part. Whole other part means these parts are needed. Whole other part other than B. So just touch here. Whole other part of B. Whole other part of B. So what is the final result? See, same figures, isn't it? So here only horizontal lines are used because what? This question is to examine the union. If intersection is needed like this, we have to use separate shadings, one for horizontal for one set and a vertical for another set, because here horizontal and vertical categorization are not needed, because what? This question is given by the symbol union. Union means what? Join up, isn't it? Complete joining up. So to make joining of both A and B, we can use only one type of shading, that is horizontal or vertical, anyone. Okay. So A union B or A complement union B complement. A complement means this one. A complement. This is A. All other part they are shaded. Then B complement means this is B and whole other parts are shaded. Then after shading for these two concepts, then look at for union, not for intersection. Look at for union. Union means whole shaded part. That is same as this shaded part. This means what? This is what? A complement union B complement. Both are same region. Therefore, A intersection B whole complement is equal to A complement union B complement. Hence the proof. Okay. See once again. De Morgan's second law. This is first law or this is second law or vice versa. We are taking this A intersection B whole complement. That is very simple. Taking universal set and marking A and B. Firstly look at A intersection B, that is this part. Its complement means all other parts. Okay. ഇത് മാത്രം ഫ്രീ ആക്കി വെച്ചു, ബാക്കിയെല്ലാം ഷെയ്ഡാക്കി. ഇതാണ് എ ഇന്റർസെക്ഷൻ ബി, അതിൻ്റെ ബാക്കിയുള്ളതെല്ലാം ഷെയ്ഡാക്കി. ദാറ്റ് ഇസ് എ ഇന്റർസെക്ഷൻ ബി കോംപ്ലിമെന്റ്. സോ ഇറ്റ് ഇസ് വെരി സിമ്പിൾ. ഇനി ഇതാണെങ്കിലോ എ കോംപ്ലിമെന്റ് യൂണിയൻ ബി കോംപ്ലിമെന്റ്. യൂണിയൻ മീൻസ് രണ്ടും വേണം, അതും ഇതും ഷെയർഡ് പാർട്ട് ടോട്ടൽ, നോട്ട് കോമൺ പാർട്ട്, ജോയിനിങ് പാർട്ട് ഓഫ് ബോത്ത് എ ആൻഡ് ബി. അതിന് വേണ്ടി ഫസ്റ്റ് യൂണിവേഴ്സൽ സെറ്റ് മാർക്ക് ചെയ്തു, എയും ബി മാർക്ക് ചെയ്തു. എ കോംപ്ലിമെന്റ് എന്ന് വെച്ചാൽ എ ഇതാണ്, എ കോംപ്ലിമെന്റ് എന്ന് പറഞ്ഞാൽ ബാക്കിയെല്ലാം ഷെയ്ഡാക്കി അല്ലേ, ബാക്കിയെല്ലാം ഷെയ്ഡാക്കി. അപ്പം ഈ വീലെല്ലാം ഷെയ്ഡ്, ഇത് മാത്രം ഫ്രീ ആക്കി വെച്ചു, ഇത് മാത്രം ഫ്രീ ആക്കി വെച്ച് ബാക്കിയെല്ലാം ഷെയ്ഡാക്കി. ഇനി ബി കോംപ്ലിമെന്റ് എന്ന് പറയുമ്പോൾ ബി, വൺസ് അഗൈൻ ലുക്ക് ഹിയർ, യൂണിവേഴ്സൽ സെറ്റ് എ, ഇറ്റ് ഈസ് ബി. What is A complement? Other than A. Other than A. Other than A. This A, other than A, A complement. Okay. Then what is B complement? It is B. Other than B. Let us take another shading to understand you. Other shading. B complement. It is B complement. Other than B. Then their union. Union means joining up. So you search for whole shaded region, complete shaded region, complete shaded region നോക്കിയാട്ടെ, complete shaded region എല്ലാം വരും. എവിടെയൊക്കെ ഷെയ്ഡിങ് ഉണ്ടോ അത് തേച്ചും, രണ്ട് ഷെയ്ഡിങ് ഉള്ളതല്ല, ഏതെങ്കിലും അറ്റ്ലീസ്റ്റ് വൺ ഷെയ്ഡിങ്, ഒരു ഷെയ്ഡിങ് ഉള്ളത് പോലും നോക്കണം. ബിക്കോസ് വാട്ട്, യൂണിയൻ എങ്ങനെയാണ്, കോമൺ അല്ല, യൂണിയൻ എല്ലാ ഷെയ്ഡിങ്ങും നോക്കി. അപ്പോൾ ഇത് മാത്രമേ കാലിയുള്ളൂ. ഓൺലി ദിസ് ഈസ് എംപ്റ്റി, ഓൾ അതർ റീജിയൻസ് ആർ ഷെയ്ഡഡ്. മീൻസ് ഇതേപോലെ തന്നെ ഇത് മാത്രം കാലി, ഓൾ അതർ all other regions are shaded, isn't it? Therefore it is what, A complement union B complement. അപ്പോൾ ഇതും തമ്മിലുള്ള ഡിഫറൻസ് ഇതാണ്. ഇത് ഇന്റർസെക്ഷൻ ആയതുകൊണ്ട് ടു ടൈപ്സ് ഓഫ് ഷെയ്ഡിങ്സ് ആർ വെരി കമ്പൽസറി. ഇതിൽ നോട്ട് കമ്പൽസറി, ബട്ട് വി ക്യാൻ യൂസ് ടു ഡിഫറെൻറ്റ് ടൈപ്സ് ഓഫ് ഷെയ്ഡിങ്. ബോത്ത് illustrations are same. Okay, right. See another question. A intersection B union C. B union C is in a bracket. Then its intersection with A. Okay. Then A intersection B and A intersection C are given, and their union. So anyway, we have to prove these two parts are equal. It is very simple. So firstly, we are taking left hand side. Left hand side is what? A intersection B union C. Yes. Then what is right hand side? Right hand side, A intersection B union A intersection C. So we have to examine whether these two concepts or these two left hand right hand sides are equal. For proving, we are drawing Venn diagram, same box, universal set U, and you are given three sets A, B and C. So it is A, it is B, it is C. A, B and C. Three sets in overlapping mode. Here also same A, same type figure, B and C. A, B and C. See, A intersection B union C. Since B union C is in a bracket, we are giving importance to the bracket B union C. So firstly, B union C is considered. What is B union C? Total region of both A and B. Join of both the B and C. Join of both B and C. B is this one, and I am shading here. B is this one. It is B. Full B is shaded. B, then C also shaded. C is this one. Full C is also shaded, isn't it? Therefore, this is B union C. Full portion of B and C. Union. By the definition of union, full portion of B and C are shaded. Then its intersection with A. So here intersection properties operation is intersection, so we have to use another shadings. It is very compulsory. Another shading. So A in its intersection with the A, so complete A is shaded by using vertical lines. Complete A is shaded by using vertical lines. Then both common both vertical and horizontal lines can be seen in particular area. Horizontal lines, this one, vertical lines, this one. So you can see two types of shadings in a particular area, and that area will be represented for A intersection B union C. A intersection B union C, which is that this area up to this. Clear? Up to this. Here you can see both the shadings. That is this one, A intersection B union C. Then same type of figure will be obtained here. If you go to same type of shadings here, then these two sides are equal. Then we have to check A intersection B union A intersection C. Firstly, we are taking bracket A intersection B. A intersection B means what? Common for both A and B. A is this one, B is this one. Common for both A and B means this one. A intersection B is common for both A and B. Union. So since it is union, no need of particular shading. A intersection C. A is this one, C is this one. So both area means what? A intersection C. This one. A intersection C. It is A intersection C. So what is total area here? Join. Union means join. Total area is this one. Same. Isn't it? A intersection B union A intersection C. So at a glance it is very clear that both area are same. Therefore A intersection B union A intersection C, this equal to A intersection B union C. They are hence A intersection B union C equal to A intersection B union A intersection C. Okay. Once again, A intersection B union C, A intersection B union C equal to A intersection B union A intersection C. അപ്പോൾ ആദ്യം ഇത് നമുക്ക് ഡ്രോ ചെയ്യാം. വെൻ ഡയഗ്രാം ABC ഡ്രോ ചെയ്തു. എന്നിട്ടോ firstly we are giving importance to the bracket B union C. Complete B and C are shaded. Its intersection with A, so another shadings for A, complete A. Then look at the common region, because what A intersection B union C, common region can be seen here, this shape. Okay. Similarly, A intersection B means what? A intersection B. This is A intersection B. Okay, right. Union. Then it is union. A intersection C. This one. A intersection C. So this one, it is A intersection B. It is A intersection C. A intersection C. A intersection C. So this union means this needed and this also needed. So this is a shape for A intersection B union A intersection C. So this shape is similar with this shape. Clear? Hence the proof. Time is up. We are going to wind up this class here. Through this class, we have learned complement of sets, similarly universal sets. By using complement of sets, universal set, we draw Venn diagram and different types of problems, De Morgan's laws also. So we are stopping here. We will meet next from next class. Okay, thank you.